Hello students, welcome back to Chemistry Online class. Today we are treating a question on electronic configuration of elements. So I'm going to teach you how to write electronic configuration before we attend this question. Now, how do we write electronic configuration of elements using the SPDF orbitals? Now, if you want to do that, there is a very short trick. We have to write S, 1s to 7 here, 2s, 3s, 4s, 5s, 6s, 7s. Then on this part, write P on the level 2. That's 2P, 3P, 4P, 5P, 6P, 7P. Then for D, we have S, P, D, F. P here starts from 3. 3D, 4D, 5D, 6D. Then there is no 7D. Then for F, we start from 4. 4F, 5F. Now, we must bear it in mind that the number of electrons that S can accommodate is 2. They are just 2. Then P can accommodate a maximum of 6 electrons. D can accommodate a maximum of 10, and F 14. So we have S maximum of 2, D 10, F 14, P 6. Now, using that, once we know the atomic number of an element, that is arranging elements based on their atomic number, at least for the first 20 elements, I'm going to pick calcium. I also pick oxygen. So if you want to write the electronic configuration, you will use the number of the atomic number, which is also equal to the number of protons and equal to the number of electrons. We use it to share the electrons on these orbitals. Then to arrange these orbitals based on their energy level, the lower energy comes first, and this is how we do it. 1s first. For instance, if I want to arrange this out, the way it's supposed to appear, 1s followed by 2s. Diagonally, we start from the edge, we end at the back. We start from the edge here diagonally. So after 1s, the next one is 2s, then we have 2p followed by 3s, then we have 3p followed by 4s, then we have 3d followed by 4p followed by 5s. The next one is 4d followed by 5p. Then we have 6s diagonally. Now the next one is 4f, starting from the edge, followed by 5d, then 6p, followed by 7p, and lastly we have 5f, followed by 6d, and then 7p. Now, bear it in mind that the lower energy level comes first, and it depends on the number of electrons they can accommodate. So the energy level numbers here doesn't really matter. That is, here now we might be wondering why we have 4s before 3d. Actually, 4s can only accommodate 2 electrons, while 3d can carry as much as 10. Now, the same thing happens here where we have 5f before 7d. Oh, sorry. Where we have 6p coming before 5f. Now, 6p is supposed to be greater, looking at the number, but because 6 can accommodate 6, p can accommodate 6 electrons on 6p here, while 5f can accommodate as much as 14, it means that 5f is greater. And so using this, you don't have any issue. Now, to write the electronic configuration of oxygen, for instance, which has an atomic number of 8, if you have issues with writing atomic number of elements, you need to memorize the atomic number of elements. You can check my video on YouTube for that. Now, so for this, for oxygen, that is 8. We have 1s2, using this, followed by 2s. What am I using here? I'm using the fact that s carries 2, p carries 6, d carries 10, and so I'm sharing the atomic number on it. So 1s2 followed by 2s2. Then 2 plus 2 is 4. It means I have 4 electrons left to share. So the next one is 2p, and 2 can accommodate as many as 6, but we have 4 electrons left because we are talking about oxygen here. So this is the electronic configuration of oxygen. To write that of calcium, for instance, calcium, which is 20, we have 1s2 followed by 2s2 followed by 2p6 followed by 3s2. Then we have 3p6. Now let's add this number together. This is 2 plus 2 plus 6 plus 2, that is 12, plus 6, that is 18. After the 3 pieces, we have 4s2. Assuming it is potassium, and potassium is 19. Potassium has atomic number of 19, so it will be 4s1. If it's calcium, it will be 4s2. That's making it 20. If it's potassium, it's 4s1. So if we want to write for hydrogen, for instance, hydrogen is just 1s1. For lithium, which is number 3, we have 1s1, 1s2, then the remaining one goes to the S2s energy level. And with that, we can answer these questions conveniently. The electronic configuration of 22x2 aeon is, now we need to differentiate between aeons and atoms. In this case, we are not referring to an ordinary element. We are referring to an aeon, meaning that it has either given out or gained. Now, whenever an element gives out, they become positively charged, and the number of electrons they give out is written on top of them. So in this case now, this X is not a symbol of an element, it's just used to represent the element. While the number down here represents the atomic number, and that is 22. Now, the number up here indicates that this element is not just an ordinary element like this, is an aeon, meaning that it has given out or lost 2 electrons. No, don't forget, when elements gives out, they become positively charged. So in this case now, the atomic number is 22, meaning that we are supposed to have proton number as 22 and electrons, the number of electrons is supposed to be 22. But in this case, it has given out 2 electrons, so it becomes 20. So we are working on 20. Now with that, you know this thing, okay, I will explain better when we get to this part. Now, so we only have here 22x2 plus, the electronic configuration is, we are working on 20, and that is 1s2, 2s2, using this chart, 2p6, 3s2, 3p6, bearing it in mind that this s carries 2, p carries 6, p 10, and f 14. Now we have 2, 2, 6, 10, 2, 6, that is 8. And the remaining 2 goes to the next one, which is 4s. Don't forget, I use this chart, 1s to 7s, 2p to 7p, 3d to 6d, and 4f to 5f, to arrange this according to their energy level. And then they are arranged diagonally. 1s compressed, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5, like that, until we got this. Now, so the best answer here is what? The best answer is option C. So you have to choose your options carefully. Now, over to the next question. What is the electronic configuration of an element 199x? Over to you, you can do this. So this 9 represents the fact that it is fluorine, though X here is not the symbol of the element. And 19 up here represent the mass number, which is another topic on its own that will be treated under isotope. So this is a typical representation of an isotope, where we have the mass number here. And mass number is the sum of proton and neutron. Here we have the number of the number of proton, and that is 9, which is also the atomic number. Atomic number is the number of proton. So here now we are working on 9, because once the proton is 9, atomic number is 9, and it means the element has 9 electrons, and it has not given out anything or gained any electrons. So we are working on 9 electrons. So 19.9x is 1s2, 2s2, following this energy level here. 2, this is 2, 2, we have 5 left, so we have 2p5. Now, thank you for watching the channel. I want you to watch out for more videos on other Jamb questions. Thank you, and don't forget to subscribe to my channel and share.